The next installment of our lessons regarding evaluating limits analytically is how we deal with rational functions. So the strategy I'm going to say here is that when you're dealing with a limit that involves a compound fraction, so that's a fraction that actually has fractions within the numerator or denominator, it's often helpful to multiply both the numerator and the denominator of that rational expression by the common denominator. It sounds kind of complicated, but when we see some of the examples, there's definitely a lot of algebra there, but it's a very doable process. So I've got two examples of that, and we'll take a look at those now. So here we go. We want to evaluate this limit. As with all limits, we sort of follow our flow chart of steps. We begin by attempting to plug in to evaluate the expression for that value. We start by plugging in 0 and seeing what happens. Right? So when I evaluate this for 0, I end up with 1/3 minus 1/3 all over 0. Nobody's surprised to see that this is 0 over 0. That ends up happening a lot. It just means we have to try harder. Right? So I look at this and say, the worst part about this problem, the ugliest thing about this problem, is that this numerator actually has fractions within it. Okay? When you look at that, there's sort of two components. There's the 3 plus h part, and there's the 3 part. What I'm going to do is I'm going to multiply top and bottom by the common denominator of those two things. So I'll sort of write it here. I'm going to do the limit as h approaches 0 of 1 over 3 plus h minus 1/3 all over h, so my original function, and I'm multiplying now by 3 times 3 plus h. And I'm going to do that to both the numerator and the denominator. And I hope it's clear to everybody why that's the common denominator. The idea is if you've got both of these factors, your denominator would have to be both of them. You'd have to share the 3 over here and the 3 plus h over here. So now, all in one step, this is suddenly going to become nice. I need to take this 3 times 3 plus h and distribute it to both of the terms in the numerator expression. When this, common denominator gets here, the 3 plus h will be eliminated, and I'll just be left with 3. So I'm going to have the limit as h approaches 0, of 3 minus. Now what happens when this term gets here? If you need to, pause the video for a second and think about that. When it gets there, the 3's will eliminate one another, and I'll be left with just the 3 plus h. And in the denominator, a lot of times we feel like we want to distribute these things out. A lot of times it just makes sense to sort of leave them as they are. H times 3 plus h. Okay, we've got all those terms, we'll just leave them there and we'll see what happens. Okay. Now that I've done this simplification, I'm going to simplify further and see whether or not I can get away with doing this limit. I've got the limit as h approaches 0 of 3 minus h over 3h times 3 plus h. Surprise, surprise, something magical happens. There's a 3 minus 3, and those combine to give us 0. So what I have left is the limit as h approaches 0 of negative h over 3h times 3 plus h. And once again, how amazing, the h's will divide out and be gone. All I have now is the limit of negative 1 over 3 times 3 plus h. And once we get to a place where we feel like we've simplified enough, we go ahead and try evaluating the expression for the value again. Let's try plugging in 0 and see if we can get away with it. I get negative 1 over 3 times 3 plus 0, so 3. That means the limit of this function is negative 1/9. Right? So the same kind of thing, like this stuff really feels like magic as you're going through it. You start with a really ugly expression, you follow some strategy to simplify, and in the end you get a really nice answer. So we've got one more that I'll ask you guys to try on your own. Alright, so here it is. Take a minute and evaluate this limit. So in this case, I think the common denominator may sort of be less clear, but the idea is up here in the numerator, I want to get rid of this fraction within a larger fraction. The only thing contributing to the denominator is that x minus 1, so I'm going to multiply the numerator by x minus 1 and the denominator by x minus 1. Now I realize as I'm starting this that I forgot my first step. My first step is supposed to be try plugging in 2, because who knows, it might work, this time. And it's a good thing to do. When we plug in 2, we end up with 1 over 1 minus 1 over 2 minus 2. Sure enough, we end up with 0 over 0. We knew we were going to need to try harder. But on your exams and your homework, there are going to be some problems where you don't need to go through all this crazy work. Plugging in the number, evaluating the expression for that value is all you need to do. With that said, let's move on. We know we need to try harder. So I'm now doing the limit as x approaches 2. Now what happens when this x minus 1 is distributed into both of these terms? When we get to the first term, the x minus 1s will divide out. I'll be left with 1 minus, and the next one will have x minus 1. And in the denominator, again, we're going to have this feeling like we want to, foil that all out and get x squared minus 3x plus 2. Don't do it. Leave this as x minus 2 times x minus 1. And let me actually briefly explain why. This is the limit as x approaches 2. The only reason this is not working is because there's an x minus 2. If I can get that x minus 2 to go away, I'll be set. Right? So I want to leave these things separated so I can cancel that as soon as I see the x minus 2. So moving on, I can simplify the top, and I'm going to skip a step up here. This in the numerator would have been 1 minus x plus 2. I'm sorry, not plus 2, plus 1. So I'm going to end up with 2 minus x in the numerator, and then x minus 2 times x minus 1 in the denominator. Then I'm going to do, what we often do in this situation. I'm going to factor out a negative and get this. And now that I've done that, we can really see that this does work out. The x minus 2's will divide out. The limit I'm left with, the expression I'm left with, is the limit as x approaches 2 of negative 1 over x minus 1. And finally, at this point, we're ready to try again. We're ready to try evaluating this expression for 2. When I try and plug in 2, I end up with negative 1 over 2 minus 1. In other words, negative 1. And that's my limit for this problem. So there's no doubt, these limits are definitely more complicated than the original factoring ones that we had. So where the radical expressions ones were also complicated. Some limits get worse. We end up with more strategies that we use to deal with them. So I hope that you guys are understanding these and that you're getting good opportunities to practice your algebra and good opportunities to practice good sort of problem writing. Notice every time I do one of these, every time I write that limit again until I use it. Right here, I don't write it anymore because I've used that limit. I'm evaluating at 2 and finding out what it is. So please be in that practice of writing down the limits each time that you use them.